All right, honors chemistry kids, we are going to do some metric conversions today, and we're going to throw in some English or British systems today. So we're going to teach you how to do those conversions, also using significant figures. You are going to need a calculator today, so make sure you've got a calculator. We are going to be crunching a lot of numbers. So the first thing we're going to try and do is we're going to try and convert Kevin Durant's height of 6 feet 9 inches into meters. And there are a couple things. This next question, what makes this problem a little bit more difficult? I think there are two things that make it more difficult. The first thing is we are mixing metric with the British or the English system. The other thing that makes it more difficult is we've got a mixed number here, 6 feet 9 inches. Now, in order to make this really work, we need that 6 feet 9 inches to all be in feet or to all be in inches. So I would proposit that being in inches is easier, so that's what we're going to do. We're going to first convert his height into inches. So on the next page, we're going to use these conversions right here for several of our ways that we are doing. So I've got a height of 6 feet 9 inches. So I'm going to work on the feet. 6 feet. How many inches are in a foot? And remember, I've got feet on the top. So on the next step, I want feet on the bottom. So in 1 foot, I hope you remember this, I've got 12 inches. Okay, so 6 times 12 will give me, let's not do this. I don't want to do this at all. Okay, this will give me, let's see, 72 inches. Okay, now remember, that just took care of this part. I still have the 9 inches. So I need to add the 72 inches to the 9 inches, and that will give me a grand total of 81 inches. Okay, so then now that I have the grand total of 81 inches, I can now use this length conversion factor to complete the problem. So I have 81 inches for Kevin Durant's height, and I see that 1 inch equals to 2.54 centimeters. I want my inches to cancel. So 1 inch will equal 2.54 centimeter. Notice my unit of inches cancel out, and I'm in centimeters. But the original problem didn't ask for centimeters, it asked for meters. So I need to remember my conversion between centimeters and meters. So if I remember this, 100 centimeters equals 1 meter. So I'm going to put the 100 on the bottom because I want my centimeters to cancel. Okay, so mathematically, every number that's along the top is going to be a multiplier, and every number that's along the bottom is going to be a divisor. So we are going to take 81, we're going to multiply it by 2.54, and then we are going to divide it all by 100. So let's take a minute to do that. So I will get this. Okay, the next thing I need to think of is my significant figures. So I know where I need to round. So this 81 inches has 2 digits here. This one is an approximation. This is not a definition, but I've got 3 digits here. So I have 3 digits here. This one is a definition. So I have an infinite amount of sig figs here. So in reality, I can only, because we're multiplying and dividing, I can only use 2 digits. So 1, 2, this 5 tells me to round up. So I'm going to report this as 2.1 meters for Kevin Durant's height. Okay? Now, The next thing I want you to do is do a gut check. Note, always make sure that your answer makes sense. For instance, it is not uncommon for a student to end up with an answer of 20,574 meters. Does that truly sound like a reasonable height for a human being? Mount Everest is only 8,850 meters tall. So you're telling me that a human being is more than twice the size of Mount Everest? Remember, do that gut check. Make sure your answer makes sense. Another thing I want to point out is this. Notice that I am always showing my units. I'm writing them out in my setup. You need to do the same. It is a really, really good habit to get into because our problems are going to get a lot more complicated. Remember, the unit you want to get out of always needs to be on the opposite side, either the top if it's on the bottom or the bottom if that unit is on the top in the next step. I.e., if I wanted to get out of centimeters, centimeters needs to be on the bottom here on this next step so that I can cancel that unit out. Okay? Remember, we're looking at units as part of the problem. So we're going to try some more. Remember, we're going to round our answers to the proper number of significant figures. I want to convert Kevin Durant's weight in pounds to kilograms. Now, do I have a conversion for pounds to kilograms? Yeah, I do. I have 454 grams for 1 pound, so I'm going to use that. So I have 240 pounds, and I want pounds to cancel, so my 1 pound is going to be on the bottom, and the 454 grams is going to go on top. But I don't want grams, I want kilograms. So there goes my pounds. How many grams are there in a kilogram? Did you say 1,000? You're right. So I have 1,000 grams in 1 kilogram. This way my grams cancel and I am left with kilograms, just like I want. Okay, remember everything on the top is going to be a multiplier and everything on the bottom is going to be a divisor. So we are going to take 240, we're going to multiply it by 454, and we are going to divide by 1,000. So 240 multiplied by 454 divided by 1,000. My calculator gives me this, 108.96. Now let's look at our sig figs here. So if I look at my sig figs, I have 2 sig figs here. Remember that 0 is not significant because there's no decimal there. It's a placeholder. This is just an approximation. So I have 3 digits here. This here is a definition. So this doesn't give me 3, it gives me infinity. Okay, so I can really only report 2 digits. So 1, 2, that 8 tells me to round up. So I'm going to report this as 110 kilograms. I could also write it as 1.1 times 10 to the 2 kilograms. Either one of these answers would work. Okay, now I want you to convert 1 gallon to liters. Make sure your answer makes sense. Okay, remember that a 2-liter bottle of soda is not, it's about half a gallon. Okay, I'm just going to give you that. So let's look at our conversion factor that we have up here. Okay, our conversion, we have 946 centimeters cubed to 1 quart. Okay, so if I look at this, that was what, 946? Okay, so, and it was to a quart. So we need to get gallons into quarts. How many gallons are in a quart or vice versa? Do you guys remember? There are 4 quarts, quarter, right? Quarter. So 1 gallon will give me 4 quarts. Okay. And then I said in 1 quart, I had 946 milliliters. Okay, let's go back to units. My gallons cancel out, my quarts cancel out. I want liters. Do you remember how many milliliters are in a liter? There are 1,000 milliliters in 1 liter. So my milliliters cancel out. Okay, so once again, everything on the top is a multiplier. Everything on the bottom is a divider. So we're going to take 1 times 4, which is 4, multiply it by 946, and then divide by 1,000. So 4 times 946, and we are going to divide by 1,000. This will give me 3.784. Okay, let's look at the sig figs here. Here I have 2. This is a definition. This gives me 3, and this is a definition. So I can report 2. So 1, 2, this 8 tells me to round up. So 3.8 liters is a gallon. How many of you guys have checked the side of your gallon milk in the fridge? It's 3.78. Actually, 3.76 if you really want to get technical. It goes a little, these approximations are just approximations. They're not super awesome. Okay, the average velocity of an oxygen molecule at room temperature is 4 times 10 to the 4th centimeters per second. Find this velocity in miles per hour. This problem requires 2 conversions. We're going to work on one, then we'll work on the other. Okay? So we have to go from centimeters to miles, and we have to go from seconds to hours. Okay? So the first thing is we've got to figure out how many miles are in a foot. Does anyone really know? I think I've forgotten that. I think it's like 5,000 something. Let me grab my papers. Let's see. It's been a long time. I don't use the English system very often, as you can probably tell, so it's not my thing. Oh, gracious. Here we go. All right, so we're going to start with the 4 times 10 to the 4th centimeters per second. We're going to work on the centimeters first. So how many centimeters are in an inch? If you remember our units that we were given up top, we had 2.54 centimeters in 1 inch. And then we need to work on getting inches into feet. So we have 12 inches in 1 foot, and this is the conversion that I needed. We have 5,280 feet in 1 mile. Okay, the next thing, so we do have miles now, which is what we wanted, right? We wanted this to be in miles per hour, right? Miles. So we've got miles. Now we need to work on hours. This is in seconds. Notice seconds on the bottom, so I need to put it on top. So how many seconds are in a minute? There's 60 seconds in 1 minute, and in 60 minutes is 1 hour. So now I have hour. So my centimeters cancel, my inches cancel, my feet cancel. I have miles. My seconds cancel, my minutes cancel, and I have hours. So miles per hour. Okay? So when we look at this, we're going to take 4 times 10 to the 4th multiplied by 60 and also multiplied by 60 again. Or we can take it step by step. Let's take it step by step. 4 times 10 to the 4th. So I would do the E button here, 4 times 10 to the 4th. If you notice, the E is the second function right above the 7. Okay, 4 times 10 to the 4th divided by 2.54 divided by 12 divided by 5,280 multiplied by 60 multiplied by 60 again, we get 800. We get 894. We get 894.7745,168. And we need to look at our sig figs now. Yep. So we've got 2 sig figs here. We've got 3 sig figs here. This is a definition. This is a definition. This is a definition. And this is a definition. So I really only have 2 digits that I can report. So that 4 tells me to round down. So I'm going to call this 890 miles per hour. Okay. Now, yes, the oxygen is running around us at about that fast, but the problem is the molecules are so small and they're all randomized. They end up pretty much canceling each other out. So we really don't feel them because the forces pushing on our body are basically zero because the molecules are so random that they end up canceling each other out. Okay, density. The density of an object is mass per unit volume. So we can use this, mass per volume, or density equals mass volume. A lot of my chemistry teachers will do it like this. Come on. They will write density is equal to mass, and they will do it like a heart. So you can remember that it's mass divided by volume, all kind of drawn like a heart. Okay? So here we go. To measure density, we must be able to both measure the mass and the volume of an object. Mass can be measured very easily on a balance, okay? Volume of a solid can be determined several ways. For instance, the volume of a cube is length of 1 edge cubed. The volume of a regular rectangular solid is length multiplied by the height multiplied by the width or the depth, okay? The volume of a liquid can be found using a clear graduated cylinder, okay? So we use that a lot. Sometimes we have to use a method called displacement, and we'll talk about that in a minute, okay? When you have an equation, there are 2 possible ways to solve for that equation, okay? We can use dimensional analysis, which we have been doing quite a bit, or you can use the method of equations. This is pretty much what you are taught in algebra. Algebra. Okay, you are taught to plug and chug. By that, I mean you are taught to isolate the variable, get that variable by itself on one side of the equation so that you can create the equivalence with the other side of the equation. Either way is correct. However, we were always in this class, we will use dimensional analysis, okay, to make sure that you understand the concept. This is the concept that we use all year long in all the classes, in all of chemistry pretty much. Okay, so what is the density of a block of lead measuring 4.37 centimeters by 6.02 centimeters by 13.68 centimeters and having a mass of 4.013 kilogram? Find the density in the standard metric units of grams per centimeter cubed. The first thing we need to do is find the volume. So the volume is going to be 4.37 centimeters multiplied by 6.02 centimeters multiplied by 13.68 centimeters. Okay, so 4.37 times 6.02 times 13.68. We will get 359. Okay, So we will get 359.885232 centimeters cubed. Now, in reality, we can really only report 3 digits. So we would say 360 centimeters cubed, but I'm not quite done with my calculation. And because I'm not quite done with my calculation, and I've got this nice calculator that will hold all of these digits for me, I'm going to keep these digits until I'm absolutely done with my calculation. Okay? So density is mass divided by volume, right? We just calculated the volume, right? So we're going to put the mass here, 4.013 kilograms, but I don't want it in kilograms. I want it in grams. So let's convert that. 1 kilogram is equal to 1,000 grams. And now I can divide it by the volume, which is 359.885. Okay? So I'm going to take 4.103 and I'm going to multiply it by 1,000. Then I'm going to divide, and I'm going to use my second key so that I can get to the answer. So second, and then down underneath the 3 is this negative. And it will give me the answer for the previous one, so I can plug that in. And I am going to, let's see, I just plugged that in wrong, so I'm going to have to plug it all in again. This is 11. I get an answer of 11.4008. We can really only do 3 digits. Remember, we are set to 3 digits here. So 11.4 grams per centimeter cubed is what we will use. Okay? What would the volume of a block of lead be that has a mass of 25.3 grams? Well, I just did the density. Can I use this density to cancel out the grams and get into centimeters cubed? I sure can. So we're going to start with our 25.3. Oh my gosh, that just changed halfway while I was writing. I think I see what the problem is. My tablet is running out of gas. That's why. Okay, let's switch this back around. That's why it was running so slow. Okay, 25.3 grams. Now I want my grams to cancel, so can I put this 11.4 on the bottom? I sure can. 11.4 grams will give me centimeters squared on top. My grams cancel, and I have my volume in centimeters cubed. So we're going to take 25.3, and we're going to divide it by 11.4. And we get this. We get 2.219298, blah, blah, blah. How many digits can I really report? I've got 3 digits here, and I've got 3 digits here. So I can do 3. So 1, 2, 3. That 9 tells me to round up. So this is going to be 2.22. And our unit here is centimeters cubed. 2.22 centimeters cubed is what I am going to have. Okay, so let's do some more. what would be the mass in grams of an irregular piece of lead that had a volume of 45.2? Well, now I have a volume. Could I take that volume and change it back into a mass using this density that we calculated earlier? I sure can. So 45.2 milliliters. Remember, 1 milliliter is the same as a centimeter cubed. They are equivalent. Okay? So for 1 milliliter or 1 centimeter cubed, I have 11.4 grams. So my milliliters cancel. So I'm going to take 45.2 and I'm going to multiply it by 11.4. And this will give me 515.28 grams. Now let's look at our sig figs. So on my sig figs, I've got 3 here and I've got 3 here. So 1, 2, 3. That 2 tells me to just leave it. So I'm going to report this as 515 grams for that block of lead. Okay. What would be that same mass or that same mass in pounds? Let's see, we have to figure out pounds now. Okay, so 515, let's get this, 515 grams. Remember, 454 grams are equal to 1 pound. So my grams cancel. So 515 times 454, that gives me, oh, my calculator spits out this 20. Oh, I multiplied. I needed to divide. That's what was going wrong. 515 divided by 454. This gives me 1.134. So I have 3 digits here and I have 3 digits here. So 1, 2, 3. That 4 tells me to keep it at 113 pounds, 1.13 pounds. Now, if I didn't round, if I kept the 515.28 and did the same thing, I would still get 1.13. It would still work out. Okay, so I would not have a rounding error. All right, when a piece of aluminum is placed in a 25 mil graduated cylinder, okay, I guess that box doesn't want to go. There we go. When a piece of aluminum is placed in a 25 milliliter graduated cylinder and that contains 10.5 mils of water, the water level rises to 13.5. So here we're using displacement. So if I start off with a graduated cylinder, that's about 10.5, and then I put the object in, that water is going to raise up once I put that object in. And when it raises up, it will raise up to 13.5 mils. And the difference between these two is the volume of the object. Now, I use difference or delta, that's this Greek symbol delta, or for change or difference. We use that all the time in chemistry and physics. So you'll see me shorthand difference or change with delta all the time. Okay, so let's get the difference here. So 13.5 minus 10.5 gives me 3. But remember, I have to the 10th, so I need to go to the 10th. So this difference is going to be 3.0 mil. That 0 is significant. I do know that digit. Okay? So what is the mass of that aluminum? I can use that. I have 3.0 milliliters of aluminum. And if I remember correctly, aluminum has a mass of 2.70 grams per 1 milliliter. So if I multiply 3 by 2.7, I will get 8.1 grams of aluminum in that block. I could very easily put it on a balance and verify that for sure. Okay, so yep, density of aluminum is 2.7 grams per mil. We said that the mass would be about 8.1. So we already worked through that. Let's look at this last problem. Is the cube at the left picture, is that made out of aluminum? So the mass is 20 and the volume is 5. Okay, so remember, density is mass divided by volume. So if I take 20 grams divided by 5 centimeters cubed, this gives me a density of 4.0 or 4 grams per centimeter cubed. Does that match the density of aluminum? We said aluminum had a density of 2.70 grams per centimeter cubed. Are these the same? They're not. So this is not aluminum. In fact, it's way more dense than aluminum. So it's a much more dense metal, probably. All right, last but not least, what is the volume in gallons of 1,250 pounds of oil with a density of 0.092 or 0.9261 gram per centimeter cubed? Okay, so we need to convert the pounds to grams. So let's start with that. 1,250 pounds. Let's just keep it there. Pounds. So 1 pound is 454 grams. Okay, that's our first thing that we need to do. Now we need to use the grams and this grams to get into volume. Okay, so when we do that, oh, stop. When we do that, we're going to put the grams on the bottom because we want the grams to cancel out. And we want the centimeters cubed to be on the top. So my pounds are gone, my grams are gone. I'm now into centimeters cubed. But I want my volume in gallons. So if I remember correctly, I had 946 centimeters cubed in 1 quart. And I have 4 quarts in 1 gallon. So my centimeters cubed cancel, my quarts cancel, and now I have gallons. All right, so we had a bunch of conversion factors here. So we're going to take this one piece at a time. So we're going to take 1250. We're going to multiply it by 454. We're going to divide it by 0.9261. We're going to divide it by 946, and we're going to divide by 4. So when we do that, my calculator gives me 161.9410139. Let's look at our significant figures. I've got 3 here. I've got 3 here. I've got 4 here. I've got 3 here, and this is a definition. So it looks like I can report 3. So here we go. 1, 2, 3. That 9 tells me to round up. So we're going to call this 162 gallons with the unit that we have left. I will have 162 gallons of oil in that. All right, that's it for today. We'll talk to you later. Bye.